For our next example, we're going to look at something that's a little bit heavier than maybe what I normally discuss with these things, but just bear in mind it's good to understand how these things can be used in a bit more of a serious context. So here, for this example, we are told that research was conducted into the 4,927 fatal police shootings since 2015, that is up to July of this year, categorizing them by race, where the pie chart given shows the result. And what we want to do is find the probability that the next incident will involve a person who is white. So here, what we need to do is essentially just find the number of incidences that have happened so far involving a white person. So you would get, for our probability that the next one is white, as 2,499 over the total amount of fatal police shootings since 2015, which, for when this data was collected, was 4927, and up to simplification, this would be our answer, where we could round this to about 0.507, which would mean that the probability that the next person involved in a fatal police shooting is about 51%. Now, as with our last example, it's important to understand the context in which some of these numbers get drawn. That here, it's a bit impersonal to think of them just as these values here when they're representations of people who were shot and killed, but beyond that, the raw data here might not tell the whole story, and it isn't guaranteed to tell the whole story anytime with empirical probability, as what we're seeing here says something different than what we might get if we look at these numbers in a more representative context. Say if we change the values from that pie chart to, instead of looking at the total numbers there, see them as numbers per million, and in that case, they might say something a little bit different. We can't necessarily decide which is the best answer, but it is important to understand that how these numbers are drawn might get you to a different answer.